Hi there. Today we're going to be looking at Chapter 4, or Topic 1. We're going to be starting out looking at numerical data. In the other couple chapters, we focused on a different type of data, and in this chapter, we'll now focus on numerical data instead. So again, in the past couple chapters, we've focused on categorical data. And when we have categorical data, that is where the possible outcomes fall into categories. So the categories that we've really been dealing with a lot are like a success failure. So like a win versus a loss. So those are like two categories that could happen. Something like again, we've really done a lot of successes failures, like a make versus a miss. But something like the position you play or color, those are things that are categorical variables because again, when they're basically descriptive. But there's also numerical data, and numerical data is something that we discussed earlier but haven't talked a ton about. Numerical data is when our possible outcomes take on numerical values. And we've discussed that it's not just all numbers, but the numerical values have to represent different quantities. And so we said that numerical data was something that could be measured. So even though like area code is a number, it's not a numerical variable because it describes where you're calling. But something like distance would be a numerical variable because you are measuring. Also, something like the number of points scored could be numerical because you are measuring how many points were scored in a specific game or by a specific person, etc. So remember, the numerical data is something that can be measured. Okay. So in chapters 1 through 3, what we did is focus on categorical data. And we dealt with hypothesis tests and test statistics that dealt with categorical data. A lot of times was successful to win, after a win then a loss, or after different situations. Now we're going to shift our focus to numerical data. We talked about 3 ways to graph categorical data. That was the pie chart, the segmented bar chart, and the bar chart. But there are 4 different ways that we're going to use to graph numerical data. One is the dot plot, and we actually have used this to represent the simulations, like the number of occurrences of our test statistic in simulations. So we're familiar with this one. Another one that we're going to look at today is the histogram. Another one we're going to look at today is the relative frequency histogram, which if you've done the histogram is going to be a piece of cake. And then in topic 2, we discuss the box plot. Okay, so again, today we're going to be focusing on histograms. So what is a histogram and what does a histogram do? What a histogram does is it divides the values of a numerical variable into classes. And I refer to these classes as like chunks of data. Okay. And what we do is it uses bars to represent the frequency of each class or of each of the chunks. So when we have something like a dot plot, in a dot plot, we can see every single point, every single result. In a histogram, it's more like they're chunked together. So like like as far as grades go, a dot plot would be something like, okay, this person got a 92, this person got a 93, this person got a 95, versus in a histogram, it would be like 3 people got between a 90 and 100 type of a thing. Okay, so it's going to be just chunks of data like that. Okay, so today we're going to look at these steps to create a histogram. And so to do that, we're going to start by finding our minimum and maximum. Our minimum is our smallest value, and our maximum is our largest value. And we do that so that we can kind of tell how big of data we're looking at. Okay. Then what we do is we divide the data into 5 to 10 equally wide classes. These are like the chunks of data that I'm talking about. Okay, and I'm going to highlight this 5 to 10. We don't want a small amount, like we don't want like 2 chunks of data because then it doesn't tell us much, but we also don't want too many chunks of data because then might as well do a dot plot, right? So usually 5 to 10 equally wide classes or chunks of data is good. And when we're deciding how to divide the data, even if our first value is 609, for example, let's start with a user-friendly number like 600 so that our chunks of data can be something nice like chunks of 10, chunks of 25, chunks of 50, chunks of 100, etc. Okay. This step 3 is going to be the biggest, I guess the longest part. We make a frequency table to organize the frequency of each class so we see how often each of the values occur in each chunk. Then we set up our axes, and then we draw our bars. Okay. The other thing I'm going just to mention real quick about drawing the bars from your histogram, make sure that these are touching, that the bars of the histogram are touching, unless there's a gap in the data. But each class should bump right up to each other. And I'm also just going to remind you guys not to forget a title. Okay. Just draw it up and make sure that our graph is clear. All right, so let's look at this example. Here are the run totals for 30 baseball teams in the 30 baseball teams that existed in 2008. And it asks us to create a histogram for this data. So let's go step by step and look at the different things that we can do. So if we look up, step 1 is to find the minimum and the maximum. When I look along the data, my minimum, I see 691, 646. That's the winner so far. 637. This one looks like the minimum. So here, notice, is our min. And then our maximum, I saw 900. Yeah, and that's the only 9. So we are going to locate our min and our max. And the other thing that I want to do is look at the range of the data. I think that's something you found before. I'm going to squeeze that here. If we take our max minus our min, we take 901 minus 637. This means that we have a span of 264 in our values, okay? And that's going to help us in our next step. Our next step is to divide the data into 5 to 10 equally wide classes. And so if we chose 264, I usually like divide by the size of the class that I want. And then that's going to kind of tell me if that was going to work. So let's say I originally thought about having classes of 100. Well, the problem is that if I divide 264 by 100, I get a number between 2 and 3. That's not between 5 and 10 equally wide classes. So 100 is too big of a chunk, okay? Then someone might say, well, what about classes of 10? Well, if I went by classes of 10, that would be between 26 and 27 classes. Again, that's not between 5 and 10. Someone might say 25. Notice that 25 goes in more than 10 times, so I think that's probably too small. But maybe something like 50. If I took 50 into 264, that goes in between 5 and 6 times, so I think that that's going to kind of be a nice value to use. Okay, so my step 2 is I'm just going to make a note that I'm going to use classes of 50. And you don't have to write this in your homework, but I want to just make sure that you're cognizant that this is like a step that you should be thinking about. And because our minimum was 637, let's not start at 637. If I'm using classes of 50, I like to use a multiple of 50. So maybe let's start at 600. Obviously, we wouldn't want to start at 650 because that wouldn't include that 637 and perhaps some other values. But if I start at 600, that 637 can be covered. Okay. So our next step is to actually make our frequency table. And when we make our frequency table, it's going to have 2 columns. And one of them is going to be the class. And then make that one kind of a little wider than this other one, which will be the frequency. And when we talk about our class, that's going to be the chunk of data. We said that we want to use classes of 50 starting at 600. So what we want is we want to go from 600. And a lot of times people will say, all right, well, let's go from 600 to 650, from 650 to 700. But there's a problem if we set them up that way. The problem with setting it up that way is that if I had 650, where do I put it? Would I put 650 here or here? If we set up our classes this way, we don't know. So then some people suggest, okay, well then let's go to 649 instead, and then 699 instead. And that might work if your data values are discrete, but if you're measuring something like distance that's continuous, where would you put something that's like 649.7 feet? So see how that's a little problematic? Also, we want our classes to be touching each other. So what we're going to do is we are not going to give like a definite ending value. What we're going to go do is we're going to go from 600 and we're going to go to anything less than 650, less than symbol. So this means 600 through less than 650. And so then I could go 650 through less than 700. Now if I got 650, I know I couldn't put it here because 650 is not less than 650, but 650 is 650, so I'd put it here. So that's kind of like a little fix. And so we can do that with the, until we make sure we encompass the maximum, which was 901. So then I would need to go from 700 to less than 750, 750 to less than 800, 800 to less than 850, 850 to less than 900. And that darn 901 makes us go have one other one, 900 to less than 950. So those are your classes. And I'm also going to highlight these 2 different things. I'm going to first highlight this through. Like these dashes mean through, and those should be there in your classes. Set up your histogram. And I'm also going to highlight these less than signs. So those are important things to have in the setup of your classes. Okay. So now that we have our classes, we're going to go through and find the frequency of each one. And there are different ways to do this. What some people do is they try to find all the ones from 600 to 650. The problem is that then you might leave some out. So the official way to make a histogram is to go through each value and then to put it into the frequency table and then to kind of cross out. So like this 782 would go in this class from 750 to 800. And just so I don't mix them up, I'm going to make dividing lines here real quick. I don't want to mix them up. So this 782 would belong in this class of 750 to less than 800. So I'm going to put a tally mark there and I'm going to cross it off so that I remember that I've looked at that one already. Now 845 would go from 800 to less than 850. 811 would also go in 800 to less than 850. 805 would also go in that class. So do you see how you work through your way through the table or through the data values, and then into the table we make different tally marks, okay? I'll give you guys a chance to do that, but I'm gonna kind of jump ahead to 700 real quick. If you look at 700, where does 700 go? Here in the 650 to less than 700, or here in the 700 to less than 750? 700 is 700, not less than 700. So that would go here in this class. Similarly, the same thing with 750. Would I go in less than 750 or what includes 750? Well, what includes 750? Okay. So see if you can go through, pause the video real quick and see if you can go through and place these frequencies in the data points in the appropriate frequencies. Okay, how'd we do? Hopefully you guys did well. One thing I forgot to mention that I sort of assumed that you might know is that when you're doing tick marks, when you get to 5, that's when you put a slash through it. So we don't have like a ton of these little sticks in a row, but the slash through it helps us count by 5s. And so these were the frequencies that I got, and I'm going to put the values, the numerical values next to it that we're a little more familiar with. So here we had 4, here I had 2, 7, 10, 5, 1, and 1. Okay, so that's step 3, and again, that one's the longest. We should be able to fly through the rest. The next thing we're going to do is step 4, which is to set up our axes. So I've just kind of emphasized the boundaries here. And it says that the horizontal axis has the appropriate numerical labels, which are going to be our class boundaries. So in our class boundaries that are here, what we're going to want to do is not list like the whole class, but just the boundaries. So I'm going to go by 3s here because I believe that should be able to fit everything in. And then I'm going to label with just the boundaries. So 600 was a boundary. 650 was a boundary. 700. Work my way down. 750. 800. 850. And then 900. But again, I need to finish that chunk off. So that's going to be 950 that's here. Okay. The other thing I should talk about in the horizontal axis is what they represent. And again, these were the run totals. So I'll just put that here. Okay. Now it says that the vertical axis is going to display the frequency. So if I'm actually trying to display the frequency, I'll label this here as frequency. And I'm only going up to 10. So I could probably just go by 1s, that's fine. You don't need to label every single piece. I'm just going to label every 2 here. So I'm going by 1s. but I'm really only labeling every 2. Okay, I don't want you to think that we can't use those, right? And that's step 4, so that's not bad. So let me write that here, that this was step 4 to set it up. And then step 5 is when we actually get to do the bars for the histogram, and then we just draw them up to each frequency. So 600 to less than 650 had a frequency of 4, so we're going to make that bar go up to 4. 650 to 700 had a frequency of 2, so we're going to go up to 2. Now we want to go up to 7 for 700 to less than 750. Then up to 10 for the next class. Do you guys see that there are no gaps because I have the continuous classes here? That's what we want. And then 5 was our next one. And then 1, and then 1. And I know it seems funny, but I've never seen a histogram that's not shaded in. So I'm going to shade in the histogram, especially because then later when we're talking about the distribution itself, we'll be able, I don't know, it differentiates it from the background. Okay, so we're filling these up. Okay, and that's what our histogram looks like. Again, our bars should be touching, but let's not forget a title. Because I did such a nice job of labeling this axis, I really need to only title it with who the run totals are for. So this was 2008, and it doesn't, I didn't say it was MLB, but they were the MLB teams. If you put baseball teams, that's fine because I didn't say they were MLB, but that's that. So that's how we make a histogram. Okay. Oh, and so this is our step 5, basically finishing it off there. All right. Okay. So that's how we make a histogram. And again, these are numerical variables. These measured the number of runs that each team had. So now let's look at a relative frequency histogram. And a relative frequency histogram shows the proportion, wow, the proportion or percent, we've used those kind of interchangeably, of observations in each class or chunk of data. Okay. So again, the histogram itself shows the number of observations. The relative frequency histogram shows the proportion or percent. Okay, that's how those differ. Oh, and sometimes a histogram is called a frequency histogram. But relative frequency is if we were to, relative frequency is when we are going to show the actual piece there. And to find the proportion or what we're going to do here to find that is we're going to divide what we found in the regular frequency histogram. We're going to divide that by the total. So again, the steps for creating a relative frequency histogram are the same as creating a histogram, except now our frequency table has 3 columns instead. We're going to look at the class. We decide on the class the same way. We decide on the frequency, but then we're also going to have a new column for this relative frequency, okay? So because I don't want us to have to go through and create another histogram, I'm just going to use the same data that we had before. So we have the run totals for the 30 baseball teams in 2008. And these were the classes that we had. These are the frequencies that we came up with. But now we're going to want to find our relative frequency. So for our relative frequency, we divide by our total. Well, if we add our frequencies up, we get 30, which is good because we said that there were 30 baseball teams that we were dealing with. So that means that we should have 30 pieces of data. And so what we're going to do to find the relative frequency is we're going to divide each of the frequencies by that total of 30. Okay, so in our notes, let's just write the over 30 in each case. If you're doing this, I don't necessarily need to see that, okay? But that's just kind of what we're going to want to make sure that we are doing. So if I take 4 divided by 30, I get about 0.13. I'm just going to round to 2 decimal places. If I take 2 divided by 30, should be half of that. So that gives me about 0.07. Please be careful rounding. Do not chop off decimals or you're not going to have a total that's close to 100% or 1. Okay. So that's going to be 0.07. Now I want to take 7 out of 30. So that's about 0.23. 10 out of 30, I know is 1/3, which is going to be 0.3 repeating, so 0.33. But if you can't see that, you can put that in the calculator and we can get that 10 out of 30 is going to be about 0.33. 5 out of 30 is going to be half of that, so about 0.17 if we round. And if I take 1 out of 30, that gives me about 0.03. And that's nice. This one is also 0.03. Now, technically, when I add these relative frequencies together, so when I add this, it should be close to what? Well, it should be 100%. Sometimes, however, we won't get exactly 100% if we add these up. And the reason that we might not get exactly 100% or 1 is because we rounded. So notice, even though I used proper rounding, I only got to 0.99. But again, that's probably a rounding error. I just want to make sure that our total should be 1 or super close. And by super close, I mean like, oops, sorry. By super close, I mean like 0.99, or if we had to round a bunch of stuff up, 1.01, okay? So that total should be 1 when we add those up. Okay, so that was our step 3. And so again, our steps 4 and 5 are similar. Our step 4 is going to be to set up our axes. Just like we did before, we can label it with our classes. So on our other one, we went from, we went by 3s, and then we just labeled each of our class boundaries here. These are still the run totals. We'll label that. And I didn't give you much room here on this side. But what we're going to do here is this is going to be labeled our vertical axis, is going to be labeled our relative frequency instead. And notice that the relative frequency isn't going to be counting like 1, 2, 3. It's going to have these decimals. Now, if we have a very high percentage, we'd want to go up to 100% or 1. But notice the biggest one I see is 0.33. So I don't need to go up to 100, like 1 or 100%. I really only need to make sure that I have that 0.33 there. So I'm not going to go by 10%, 10, 20, 30, because then everything's going to kind of be crammed in here. I don't want to go by 0.01 because I don't have enough room. So pick the smallest unit you can that'll fit, and that's going to be 0.05. So if this is 0.05, this is going to be 0.1, and I'll say 0.10 since I put everything to 2 decimal places here. 0.15, this is going to be 0.20, this is going to be 0.30, 0.40, and we technically don't need to label anymore in this case because we're only going up to 0.33. Okay. All right, so now we're going to draw the bars to the appropriate spots. So from 600 to 650, we're going to go up to 0.13. So 0.13 is going to be a little less than 0.15. 0.07 is going to be a little more than 0.05. 0.23 is going to be between 0.20 and 0.25. Okay. So just kind of guesstimate your best as far as where these are going to land. Usually people don't have a problem with this. Okay. And then again, I will ask real quick to shade these in. Just so they're differentiated. Shading's also therapeutic for many people, myself included. All right, so that looks nice. Only thing we are missing is a title. And again, we can say that this is the 2008 MLB teams. And I don't need to put that it's the MLB run totals because I did such a nice job of labeling our axis here. Okay. And I think that does it. So thanks for putting up with this video. I know I had a couple glitches there, but hopefully you are ready to do homework on histograms. Okay. Have a blessed day.